Okay, so the only thing I need to add for today for 16.4 is intersection problems. And that's where I have two equations, this equation, which is in polar, and this equation, which is in polar, and I see where they intersect. Okay? If I could graph both of them, and I know r equals 1 is easy, it's just a circle with a radius of 1, and the other one's graph, let's say it was up here, where would the answers be? It would be where the two graphs, what? Intersect. Okay, so that's essentially how you do intersect problems if you were going to graph them. But what if we didn't want to graph them? What if I had two regular equations, x equals 5 and 5x plus 1 equals 12? How could I get those to be solved? I could graph them and see where they cross, or couldn't I just substitute and stick the one in the other and solve? So couldn't I just substitute, stick the one into the other, and then solve? Yeah. So if r equals 1, and I see an r over here, I could make it equal a 1, right? And then I'd have 1 is equal to 2 sine of 2 theta. Yeah, but 1 squared is 1. But yes. Okay. What if it had been 2? You'd have squared it and you'd put in 4. Right, so I guess I glossed over that too quick. That just goes there, and then I say 1 squared, and then 1 squared is 1. Or if it had been a 3, then I'd put a 9 here, etc. Okay, good enough. So now I stuck that in, and now I'm going to divide both sides by 2. And now I've got sine of 2 theta. Ooh, do you know what that is? Have that one memorized yet? Sine of 2 theta has come up enough times. You should have this puppy by now. 2 sine cosine. But if I can solve that, then I'll have my answer. What I'm trying to get you to do right this second, considering how little time we have left, is just to get the idea that you can stick one equation into the other equation and then solve it. Like this one. Look at this one. Do you get that I have r equals something and r equals something? Anytime you have two things that are equal to each other, then I like to think of it this way. I could just put this one in for r, because it says it's equal to r, so then it's cosine of theta plus 2 is equal to 4 minus square root of 3 all over 2. And then how do you solve something like that? Once again, let's say I had got it down to something like this. Cosine of theta is equal to 1/2. Would you know how to solve that? It's a circle trig. So we just got to get it to be something like that. So it's just got a few little complicated steps along the way. Like you got to subtract 2. Well, that's not that hard over here. But over here, it's not so nice because it doesn't have a common denominator. So then you got to get a common denominator and simplify it all down. And what if you end up saying cosine of theta is equal to negative root 3? Let's say it was just that. Then that means it's over 1, and you could do circle trig and figure out where cosine is negative. Cosine's positive here and here. So it must be over here that you would draw your triangles, etc. So you know how to do circle trig. I want to not have to review all of that. So what's the new thing for today? Got two equations. Substitute, stick the one in the other, solve. All right. So what we do tomorrow is a review day where we do some more of these kind of questions. You'll have a few of these for homework for tonight. And we did most of the review of the other stuff, the stuff you just practiced in class a few minutes ago, that homework quiz that we did in class. That one was gathering or practicing a lot of the stuff that you'd need to know for the test. All right. So then there's the intersection points, what we were just talking about right now. We'll review that again tomorrow. And you got to do some for practice, sticking the one equation in the other and then actually solving it down. They'll look something like this, and that's circle trig, and you should know how to solve circle trig kind of questions. All right. You usually work out to angles that you already know. We already practiced this kind in class. All right, so let's get to the actual homework for tonight. I'm going to pause while I find. Okay, assignment 16.4. And a couple of intersection problems. Again, we have a nice answer key posted for this. It's got all the work shown. I know I had to do this really fast with you today, but there's an r equals. There's an r equals. Set them equal to each other and solve. And yeah, you're going to have a sine on one side and a cosine on the other side. And you'll have to figure out how to get those together Either you're going to set them equal to 0, or you're going to divide them, and then the sine over cosine would be tangent, for an example. But anyway, one thing at a time, set them equal to each other, and then try to solve that equation. All right, so these two, I'm depending on you going and looking at the answer key and getting a feeling for if you understand how to do these or not. All right, and then this is back to that other kind. Do you remember those definitions? X squared plus y squared equals what? R squared. So right away you can pull out x squared plus y squared and put in an r squared, and you just changed it from what kind? Rectangular into what kind? Polar. All right, you got to practice that a little bit. Those are not that easy. I bet you that's one of the ones you spent more time on than normal. So try these 3 questions of that old style. And let's see. I think we've practiced these enough. If you feel like you need more practice, you can do them, but I'm not assigning them. All right, so these 2 problems of the new stuff, and then these 3 problems of the review stuff, and that's all I need you to do for homework for tonight.